Okay, chapter 6, section 2. We're going to start multiplying polynomials. First off, a term is binomial. It's a polynomial with two terms. So an example would be 4x squared plus 2x, or something as simple as x plus 3. When multiplying polynomials, we have to recap our exponent rules. So remember, when you multiply, you add your exponents. So if we have 5x times 6x cubed, that's technically going to be 5 times 6, which is 30. And then you're going to take x times x cubed. So remember, it's going to be x. And since this does not have a exponent, it is assumed to be 1. So there's technically a 1 there. So I'm going to say 1 plus 3. So my answer is going to be 30x to the 4th. Same thing over here. I'm going to take and multiply everything that's similar. I'm going to multiply my coefficients. So 4 times 2 is 8. X squared times x to the 6th. That's going to be 2 plus 6 is 8. So that's going to be x to the 8th. I'm going to combine my y's together. So I'll have y to the 3rd times y to the 4th, which would be y to the 7th. And then there's nothing else I can multiply with that z, so it's just going to follow along. Nothing that we have to do with it. So then your answer here would be 8x to the 8th, y to the 7th, z. So remember, we're going to recap the FOIL method. Just like when we were multiplying complex numbers, we did the FOIL method when we were multiplying two binomials. So when you multiply two binomials, you get a trinomial. When we were doing complex numbers, we still got a binomial because of that I squared equaling -1. But when you do this with x, with any variable, as long as it's not an I, you get a trinomial. So again, we're going to do the FOIL method. So I'm going to take my first term. So 2 times 1 is 2. I'm going to take my outer terms. 2 times x is going to be a plus 2x. My inner terms, 3x times 1 is going to be a plus 3x. And my last terms, 3x times x will give me a plus 3x squared. So now we have these two middle terms that are like terms. So my final answer here is going to be 2 plus 5x plus 3x squared. And you can leave it written like that, or you can go ahead and rewrite it as 3x squared plus 5x plus 2. Now, when you multiply a binomial times a trinomial, you're going to take everything that's in your binomial and make sure you multiply to each thing in the trinomial. So pretty much like the distributive property. So I'm going to take x times 1. So x times 1. I'm going to take x times a -4x. And you're going to be sure to be adding, or you can go ahead and follow the signs. X times 2x squared is next. And once we go through with the x to each term, we're going to go through with the 2. So we're going to have 2 times 1. And then we're going to take 2 times -4x. And then last but not least, we're going to take the 2 times 2x squared. So we're going to multiply and add. We'll have x minus 4x squared. X times 2x squared is going to be 2x to the 3rd. 2 times 1 is 2. 2 times -4x is going to be that minus 8x. And then 2 times 2x squared is going to be plus a 4x squared. So now we have to combine our like terms. Looking through this, x and negative 8x is going to give me a negative 7x. So those are done. Negative 4x squared and 4x is just going to cancel each other out. There's 0. So there's nothing there. And then we have nothing that we can combine as 2x cubed and the 2. So I'm just going to carry those down. Again, rewrite it, highest exponent to lowest exponent. So we're going to have 2x cubed minus 7x plus 2 as your final answer there. So FOIL method when multiplying two binomials. Distributive property when multiplying a binomial times a trinomial, taking each term and distributing it into the other. Word problem. So just like with adding and subtracting, modeling, we're going to model here with multiplication. So we have Mr. Silva manages a manufacturing plant. From 1990 through 2005, the number of units produced in thousands can be modeled by n of x equals 0.02 x squared plus 0.2x plus 3, x being the number of years since 1990. The average cost per unit in dollars can be modeled by c of x equals 0.002 x squared minus 0.1x plus 2, where x is the number of years since 1990. Write a polynomial t of x that can be used to model Mr. Silva's total manufacturing costs for those years. So in order to find the total, since we were talking about each year, what the cost was, and what the number of units were produced, in order to find the total cost, you take the number of units produced times the cost to produce a unit. So t of x is what we want to find, is going to equal n of x times c of x. So we're going to go ahead and multiply those two trinomials. So t of x is going to equal 0.02 x squared plus 0.2x plus 3 times 0.002 x squared minus 0.1x plus 2. So your book goes ahead and lines these up. We're going to do old school multiplication pretty much. We're going to say 0.02 x squared plus 0.2x plus 3. And we're going to multiply that by negative 0.002 x squared minus 0.1x plus 2. So we're going to go ahead and multiply these. 3 and 2 is going to give me 6. 0.2 times a negative 0.1 is, or 2 times 0.2 is going to be 0.4x. And then 2 times 0.002, or 0.02, is 0.04 x squared. So old school multiplication, just like if you were multiplying 3 digits. 2 times 3, 2 times 0.2, 2 times 0.02. Then we're going to do the same thing here. We're going to take the 0.1 times 3. So we're going to leave that 0. We'll then have a minus 0.3x. 0.1 times 0.2 is going to be a minus 0.02 x squared. And then 0.1 times 0.02 will be the minus 0.002 x to the third. And then one more time, I'm going to take the negative 0.002 times 3, and that's going to put us at negative 0.006 x squared. Negative 0.002 times 0.2 is going to be negative 0.004 x cubed. And then negative 0.002 times 0.02 is going to be negative 0.00, 4 zeros and a 4, x to the 4th. So now, old school multiplication, 6, we're going to have, since we're subtracting, 0.1 x. Subtracting everything here, we're going to have 0.014 x squared. Subtracting here, we're going to have negative 0.024 x cubed. And then we'll just have that negative 0.00400. 4 x to the 4th. So let me rewrite that for you guys. T of x is going to equal negative 0.0004 x to the 4th minus 0.0024 x to the 3rd plus 0.014 x squared plus 0.1x plus 6. So that is all you need to find. We're not plugging anything else in. So that was a little bit confusing. Let's recap again. Multiplying the trinomials, technically you would do the distributive property and multiply everything through. Multiply everything through, multiply everything through. We went ahead and set it up in an old school multiplication way where we lined everything up and we took each thing times each thing and then subtracted. So 2 times 3 was 6, 2 times 0.2 was 0.4, 2 times 0.02 was 0.04. Then you skip over a space. 0.1 times 3 is 0.3. 0.1 times 0.2 is 0.02. 0.1 times 0.02 is 0.002. Again, subtracting. And then doing that with the same, just multiplying. So old school multiplication. You could also probably type the numbers into your calculator. That would kind of work, but I would rather see this setup of the old school multiplication. So your answer here is T of x equals negative 0.004 x to the 4th minus 0.0024 x cubed plus 0.014 x squared plus 0.1 x plus 6. Example 3 is verifying polynomial identities. Polynomial identity, any identity in general, is when something is equal to something else. So a polynomial identity is a math relationship equating one polynomial to another. So this right here is a polynomial. This here is a polynomial. We're going to prove that this side equals this side. And the reason why we're going to make this side equal this side is because this cannot be simplified anymore. 4ax is as simple as that can go. This definitely needs some work. So, biggest thing I want to point out, biggest mistake made in algebra. This right here, this whole thing squared does not mean that x is squared, a is squared, and you're done. That is not what that means. That means that this whole thing is multiplied by itself. That is one of the biggest mistakes made in algebra. So I'm going to say x plus a times x plus a. That's what that is meaning. Anything when you have a quantity squared, means that it's this binomial times this binomial. Same thing here. I'm going to subtract. I'm going to say x minus a times x minus a. So I'm going to make this side look like this. If we can do that, then we have proven the identity. So FOIL, x times x is x squared. X times a is ax. A times x is ax. A times a is a squared. I'm going to keep the parentheses because that's that one polynomial. I'm then subtracting. I'm going to do the same thing here. X times x is x squared. X times negative a is a minus ax. And then we have another minus ax. And then we have a plus a squared. I'm going to work inside each set of parentheses. So I have x squared plus 2ax plus a squared, still keeping that in the parentheses, minus x squared minus 2ax plus a squared. Okay, so now we have two trinomials being subtracted. So again, rewrite without parentheses, as I've always said, x squared plus 2ax plus a squared minus, distributing this into everything. So minus x squared plus 2ax minus a squared. So now you can see x squared minus x squared, those cancel out. Nothing's there. 2ax and 2ax plus 2ax is 4ax. They are like terms. So we're done with those. And then a squared minus a squared is just going to cancel out as well. So we have 4ax equals 4ax. Your identity is true. So put a check mark. 4ax does equal 4ax. If you got something other than 4ax on this side, the identity would not be true. And always double check your math just to make sure. So we can say that the statement is true. Last but not least, we want to use those identities that we're going to prove. So the following can be used to identify Pythagorean triples. And Pythagorean triples are using the Pythagorean theorem from geometry. That would be like a triangle with the sides 3, 4, and 5. That is a Pythagorean triple because it is perfect numbers. 3 squared plus 4 squared equals 5 squared. So 9 plus 16 equals 25. That is a true statement. So this polynomial identity can be used to determine that. It's telling you this is my identity. It's telling us what x and y are. That means all we have to do is plug these values in to this identity. Plug and chug. Those are my famous words. So we will have 4 squared plus 3 squared. And that's all squared. And that's going to equal 4 squared minus 3 squared. And that's all squared. Plus 2 times 4 times 3. And that's all squared. So work inside your parentheses first. Order of operations. 4 squared is 16. 3 squared is 9. And we're going to square that. That's going to equal 4 squared is 16 minus 9. And that's going to be all squared. Plus 2 times 4 is 8. 8 times 3 is 24. So 24 squared. 16 plus 9 is 25. 25 squared is going to equal 16 minus 9, which is 7, plus 24 squared. So technically, if you look here, this is the Pythagorean theorem. A squared plus b squared has to equal c squared. So they're saying the numbers 7, 24, and 25 are a Pythagorean triple. So we're going to see if that's true. 25 squared is 625. And that is supposed to equal 7 squared is 49. 24 squared is 576. So 49 plus 576, that is 625. So 7, 24, and 25 is a Pythagorean triple. 625 is equaling 625. That statement is true. If you put this in your calculator, you have to be very, very careful. Your calculator may not do the order of operations correctly. I suggest doing it just like I did it. Take it piece by piece. Do your order of operations. Work with your brain, not with the technology. You all can do this. With that being said, that is the end of section 2 for chapter 6. And we are going to make your homework page 212, 213, numbers 2 through 20 even. So page 212, page 213, numbers 2 through 20 even are the homework problems for this section.